Hello everyone, this is Sam. Today, me and my partner Wong Chun Sing will be talking about the definition of output feedback mode and we will explain how it works. We will go through one by one to explain the output feedback mode. We will explain the definition of it. We will talk about the encryption and decryption of how the output feedback mode works. And then we will talk about the advantages and disadvantages of having them. Introduction. What is output feedback mode? Output feedback mode is also stands for OFB. OFB is a mode of operation for block cipher. OFB is very similar to the ciphertext feedback mode, which is CFB. It allows encryption of different block sizes. The only difference between them is the line from step 1 to step 2. OFB has the key difference that the output of the encryption block function is the feedback, instead of the ciphertext. The OFB mode requires a nonce, an initialization vector, which is IV, unique to each execution of the encryption operation. Sequence of encryption output blocks depends only on the key and the IV, and not on plain text. Now, we'll be talking about the encryption of the OFB. So this is the first step of the encryption of the OFB. We'll have the initialization vector first, which is the IV. So what is the IV? The IV is a random string of bits, which is used to add more randomness in the encryption process. And then we'll have the key. So what is the key? The key is used for encrypting the initial vector to produce encrypted initial vector, which is the output. So the output is an encrypted vector encrypted by the key. And the key bits, which is a 64 bits, this bits is predefined as the initialization vector, which is also 64 bits. Now we will go to the step 2. So the step 2, we will take the first j bits of the encrypted initial vector. So what is the j bits? For instance, the initial vector has 8 bits. So the initial 8 bits is 10110011. And then after encrypting the initial vector, we'll get an encrypted vector, which is 1110101. So for example, if we are doing a 4 bits, we will take the first 4 bits out from the 8 bits. So as we said, the encrypted vector here is 1110101. We will take the first 4 bits, which is 1111, and then we will also take another first 4 bits of the plain text, because j is equal to 4. Then we perform XOR operation, which is here, the circle right here, between the first 4 bits of the encrypted initial vector and the first 4 bits of the plain text. Then we can get the ciphertext block 1. For step 3, we have to perform left shift of initial vector by j position for the new initial vector, which is here. So as I said, j is 4. And then the initial vector is 10110011. And then if we perform a left shift, we will get 0011, the last 4 bits. Then we also have to perform j bits of the encrypted initial vector from here into the right side of the new initial vector. The encrypted initial vector is 11110101. We take the last 4 bits and we put it into here. And then we combine it together, we will get 0011 and 1111. And then we will do the same. We will encrypt it with the key, and then we will get the new encrypted initial vector. And then we will take the first 4 bits and complete an XOR operation with the plain text of the first 4 bits, and then we'll get the new ciphertext again. Now we'll be talking about the decryption process of the OFB. The decryption process of the OFB is actually quite similar to the encryption. The only difference that is the ciphertext here and the plain text here swap places. The decryption process will also have the initialization vector, and it will be encrypted by the key to produce an encrypted vector, and then we will also take the first J bits of the encrypted initial vector here, and then we will perform an XOR operation with the first J bits of the ciphertext here, and then we will generate the plain text block 1. And for here, we will also perform left shift of initial vector by J position for the new initial vector. So we also take the first, we also perform a left shift from the initialization vector here, and then we'll put it in here. And then we also have to perform the J bits of encrypted initial vector into the right side of the new vector. And then the key here is also to encrypt the new initial vector, and then we'll produce an encrypted vector here. And then we also take the first J bits of the encrypted vector, and we'll perform the XOR operation with the first J bits of the ciphertext, and then we'll produce the another plain text block 2. Now, we will be discussing about the advantages and the disadvantages of the OFB. The advantages of the OFB is that the plain text of the same word is not equivalent to the ciphertext with the same representation. The bit error in transmission will not propagate. Error in one ciphertext block will only affect the current block's plain text. The encryption in the blocks are independent from the data, which helps with the protection of the key. OFB encryption is non-deterministic, in that encrypting the plain text twice or more result in a different ciphertext. The disadvantages of the OFB. The sender and receiver must be in sync during the process. For example, having the same initialization vector, be able to know the number of blocks of output to compute or pre-compute during decryption. It is vulnerable to message stream modification attacks. It is also unable to perform parallel operations. That's all for the video today. Thank you.